Hello, I'm Sandy and I'm the lead engineer on the open source Dagster project. And today I'm here to talk to you about Dagster and data quality. Data orchestrators, like Dagster, help data engineers deliver data. They run computations to produce the data, and they help organizations understand that data, where it comes from, where it's used, and whether it's up to date. However, not all data is high quality data. If the orchestrator is helping you deliver data that's low quality, or just plain incorrect, that could be worse than delivering data late or even not at all. Because of this, we believe it's not enough for data orchestrators to just help deliver data. They should help deliver high quality data. This is why we developed a new feature as part of our latest release that allows defining data quality checks on Dagster assets. Dagster leaves it up to the user to decide how they want to express their business logic for data quality checks. You can code them from scratch in Python if that's your thing, or you can write them using frameworks like dbt tests or Great Expectations. However you write your checks, Dagster takes responsibility for executing those checks as part of your data pipeline, and it makes the results accessible when you're monitoring the success of your data pipeline. This feature, which is tightly integrated with Dagster's software-defined assets, makes Dagster the only orchestrator with first-class support for data quality checks. Before we explain how all this works in more detail, I'm going to step back to give a little background on what data quality checks are and why we believe that orchestrators should care about them. Data quality checks are a powerful technique for ensuring that your data is not garbage. The basic idea is that after generating your data, you run some code that inspects it and verifies that it looks like you expect it to. If your data fails the check, you have the opportunity to investigate why and to fix it. For example, you might want to verify that the user ID column in one of your tables contains no null values, or that all the dates in one of your tables are formatted in the way that you expect. And data quality checks aren't only for tabular data. You might want to perform a check on a trained machine learning model to make sure that there aren't too many dead neurons. Data quality checks are, of course, not a new idea. There's a lot of software out there that helps people define them. Open source tools like dbt tests and Great Expectations, as well as proprietary products like Big Eye and Monte Carlo. Many organizations build their own. I've done this in the past. However, to effectively operationalize these data quality checks, we believe that the orchestrator needs to understand them. Orchestrators can't just treat tasks as black boxes that sometimes happen to execute data quality checks. They need to treat data quality checks as first-class citizens. And there are a few reasons why. First, it allows a unified view of the data pipeline in a single place. Orchestrators are already the source of truth on what succeeded, what failed, and where data comes from and goes to. If the orchestrator also understands when data fails its quality checks, it's uniquely able to provide a full picture of the health of each data asset and the pipeline as a whole. Second, data quality checks are work, and work needs to be orchestrated. We've even heard some users tell us that the vast majority of their cloud bill comes from executing data quality checks. Without an orchestrator, it's difficult to track when these checks are executed, to make sure work happens in the right order, and to pick up where you left off when there's a failure. It's easy to execute checks too often or not often enough. Third, data quality checks are often an input to other orchestration decisions. When data doesn't meet your quality bar, often you don't want to let it spread to downstream assets in your pipeline. An orchestrator that understands data quality checks can skip downstream computations when upstream checks don't pass. And finally, data quality checks combined with a declarative data orchestrator like Dagster help to define contracts for your data assets. With the software-defined asset approach, the orchestrator is a source of truth on what assets make up the pipeline. It's natural to extend this so that the orchestrator understands what data quality checks are defined for each asset. It can then present a reliable view of what the data in the pipeline is intended to look like, which acts as a shared point of reference for data pipeline developers and their stakeholders. With that, I'm going to hand it off to Tim to demo how Dagster's data quality check support works.
Thank you, Sandy. As you just heard from him, data quality is a critical part of any data team's workflow, and hopefully you have a better understanding as to why data quality checks should be orchestrated and how Dagster enables that with asset checks. I'm Tim with the Dagster team, and now we're going to look into how exactly you can define and use asset checks in Dagster. In Dagster, asset checks are defined the same way that you define assets, which is by writing code. Here we have a simple asset that ingests data and writes it to a CSV file. Let's imagine that we want ourselves and our stakeholders to be confident in using this data. So we want to add asset checks to it. Here's how we do it. First, let's import a couple things from Dagster, the asset check decorator and asset check result. Then we'll write a function that tests the data quality of the asset and just add the asset decorator on top, similar to how you decorate a function that produces an asset with the asset decorator. We'll call this function noNullOrders. In this function, we'll read in the CSV file produced in the asset definition and then do whatever we need to test the data quality. In this case, that's checking that the customer ID column doesn't have any null values. After that, all we'll have to do is return an asset check result with a Boolean expression that evaluates to true if the asset check passes and false if it fails. We can also attach relevant metadata to this. In this case, we'll attach the number of null values that we found and the number of rows ingested. As Sandy mentioned, that'll not only help us verify the quality of the data over time, but also creates data contracts and sets expectations with your downstream users on what the data should look like. Now that we have it defined, let's see what this looks like in the UI. Here is our asset graph. What is new is that if an asset has an asset check, you'll see that the assets node now has an additional section dedicated to showing you the latest evaluation of its checks. This is a great way to see the health of your data. The asset graph has always been empowering to see what dependencies are and when assets were last updated, but now we can see even more of the health of your data pipelines all in one centralized place in this asset graph. We can see where the data doesn't match the standards for quality that we have set, or it doesn't match the contracts that we have defined. Let's run the asset with the asset check. Here, you'll see the asset check execute with the asset after it successfully materializes. And just like any other step or asset, you'll see logs and events being streamed about the asset check during the run. Now, the asset graph covers the most recent evaluation, but you can also see the historical runs and compare them over time. Let's click into the assets page in the asset catalog to see this. You'll now see a new tab called Checks, which contains a table of all historical evaluations of the asset checks, along with data such as what materialization they were associated with, the run the asset check came from, and the metadata associated with its evaluation. Asset checks are a flexible and composable API. Dagster is not here to strictly prescribe what data quality means for your organization. Instead, we provide a set of fundamental functions and building blocks that you can use to build your own data quality framework. Having these fundamentals in place means that asset checks can be shaped to work with your needs or tooling. For example, we proudly maintain a DBT integration that maps every DBT model to a Dagster asset. And one of everyone's favorite features of DBT is the ability to add tests to your DBT models. And with asset checks, we showcase this by also mapping every DBT test to a Dagster asset check. If you are using our DBT asset integration released in Dagster 1.4, you can opt into this by setting a flag in your Dagster DBT translator object. Let's look at this on our asset graph. Now you'll see that each DBT model has its corresponding asset checks associated with it, and the names of these checks match exactly with the names of the DBT tests from your DBT project. Most importantly though, is that this functionality is enabled using the same asset check APIs that are available to you. So you too can provide abstractions to generate many asset checks at a time. Now that you're familiar with what a basic asset check is, let's show a case that stitches everything together by showing you what it means to truly embed data quality into your orchestration. Let's say we have an asset for the number of sales we make each day. We'll call this a daily sales report. And we want some basic anomaly detection to tell us whether or not we have too many sales or too few sales for the day. Let's write an asset check for this asset. With asset checks, you have access to the rest of your Dagster instance. For example, this asset check fetches all the previous materializations of our asset, understands what day it is trying to materialize, and gets our reported metadata from each historical materialization. The idea of using your metadata is a powerful pattern available to you with Dagster. Because Dagster is the single pane of glass across your data platform, you can access any information you may need to test your data quality. With this metadata, we'll do some simple summary stats on it and point out any outliers. I mentioned earlier that we want to be enabling and not prescriptive in how data quality is defined and how asset checks are used. Therefore, you can define what is considered anomalous for your assets at a very granular level. As you can probably tell by now, there is an endless realm of possibilities available to you with asset checks. And I can talk all day about different ways you can use asset checks, but I'll save you that and just highlight some of my favorite. With asset checks, you can make data contracts and watch for schema drift and react to it in different ways. For example, you can raise an alert and error if any existing columns are changed. Or you can just raise a warning if any new columns are added, therefore empowering and informing your downstream stakeholders. And as you saw in the previous example, you can monitor data drift and compare materializations over time. You can also run a check before materializing and block that asset materialization from happening if it doesn't match the data quality standards that we have. And finally, you can programmatically make factories that generate asset checks for multiple assets. This enables you to make domain-specific languages that you can share with your stakeholders, empowering them to define data quality and make asset checks without ever writing a single line of Python. Let's talk briefly about Dagster Cloud. A perk of Dagster Cloud is that alerting comes out of the box with alert policies. And previously, you could set alerts based on heuristics like if a run or a deployment failed. As of this week, you can also set alerts on individual assets and the checks associated with them. And for the time being, while asset checks are still experimental, they will not consume Dagster credits. All right, in conclusion, you've just learned how asset checks can be used to monitor data quality in your pipelines. You've seen the Asset Checks API and how to use it with the rest of Dagster. And you've seen not only how to navigate the UI to see asset checks, but more importantly, understand the health of your data pipelines all in one place. All right, that's it for today. Tune in tomorrow for the next day of launch week. Today, we talked about how embedding data quality in your data orchestrator enables you to understand the health of your pipelines. And tomorrow, we'll show you how to run your pipelines efficiently and keep costs down with Dagster Insights. All right, catch you tomorrow. Take care.